Hello friends, welcome to MAPHCH YouTube channel. Today in this video we are going to study a topic named as logic gates. Trust me, in the JEE Mains the logic gates will give you only +4, no -1. In JEE Mains the logic gates is only the topic that will definitely give you the +4. And today in this video I am going to explain the entire topic in detail to solve the problems. Remember, we are going in the perspective of to solve the problems only. I am not going to take much time of you, and you can make the short notes from this. First of all, what is logic gate? A digital circuit which allows a signal to pass through it only when few logic reasons are satisfied is called as a logic gate. What that mean? A logic gate is a kind of a digital circuit which allows only specific kind of a signals which have some logic in them. What that mean of logic? That a signal should have a logic? Yes, it should satisfy some criteria to pass from the logic gate. Imagine that a logic gate is just a circuit. To pass through that circuit, the signal should have a specific character. That character should match the digital circuit, so that digital circuit can allow that signal to pass through it. Okay, this is a basic information of the logic gate, nothing else. Next, coming up to what are the types of logic gates. We will discuss for some time about these logic gates, what are the types of them. First of all, we will start with the basic kind of logic gates, that is NOT gate, OR gate, AND gate, XOR gate, XNOR gate, NOR gate, NOR gate and NAND gate. What are these? Are they a bit confused for you? No, they are very easy to remember. How we can remember these names? It is very easy. I will tell you. Wait. Here you are seeing an arrow. It's not an arrow. For example, I am telling you how to remember this NOT gate. This is NOT gate, but how to remember? Are you seeing? Can you see this small knot here? Remember this small knot as the NOT gate. It has a specific character that I am going to tell you in the next few minutes. It will be very clear to you. So as for now, how to remember, I am telling you. See here a small knot, a small bubble type structure, we will call it as a knot, and remember this whole gate as the NOT gate, nothing else. This is OR gate. This is just like this, a small curve and a small bump, nothing else. It will have two signal receptors and one living signal receptor, that is another. This is in the form of an O. Can you find a half circle here? Half circle, you just remember it as O, and we can call it as OR gate. Okay, for this, do you know how to write AND? We will commonly write AND, right? A N D. This D, we can remember it as D like this. This is D, we can remember it as like this. But what we can prove from that? Nothing. I am going to tell, I just want to tell you that it is an AND gate. In the A and D AND, we are having D like this, and this gate is also in the form of, in the letter of D. Just better to remember this as AND gate, nothing else. Now coming up to this XNOR gate or XOR gate, we are not having any much use in this JEE Mains portion, but just remember the structures. Bring this OR gate here also. Just keep a bracket like this inside the OR gate. Just keep this bracket like this and remember it as XOR gate, nothing else. For the same XNOR gate also, you keep the same bracket and keep a NOT. It will become XNOR gate, nothing else. Now coming up into this OR gate and AND gate, how to remember those? It is a mixed of hybrid. Why I am saying like that? You can see here OR gate, here you can see AND gate, and you can see NOT gate. How these gates are formed? While intermixing of three gates, these two gates has been formed. How, sir? How we can do? How we can remember? Nothing. Take this OR gate here, drag this out, and take this small portion of NOT gate and attach it here. Then how we can name it? We have included this OR gate here, we have included this NOT gate here. I will take N from the NOT and OR from the OR, and I will mix the word as NOR. Nothing. Quite simple. And how this AND gate is formed, sir? Nothing great. Take the AND gate here, drag it out, and take this NOT gate part and attach it to here. Now I am taking AND and NOT not, but I am taking only N and attach NAND NAND gate. Don't forget these, as these are the universal gates. From this only we will form the all kind of gates, and these gates are the problems that we are going to solve. These two gates are very important. Don't forget them. Just remember. I will explain you each and everything about these logic gates, and we will solve the problems also. Okay? Don't worry. Now, what is a truth table? A truth table which shows all possibilities, inputs and outputs combinations is called as truth table. What is a truth table? First of all, a truth table is that which shows all the possibilities of inputs and outputs. If we give an input, for example, for this NOT gate, if we give an input of a signal, then what will be the output? The truth table will show that. Did you got? What I am saying is, the truth table is a table that shows the input and an output of a specific logic gate. Did you got? The truth table is a table that shows input and output information. nothing more. See, each gate has its own truth table. Each logic gate is having its own truth table. Okay, each truth table gives its a unique information. Each truth table will have a unique information about the specific logic gate, nothing more. The truth table, to solve the problems, I say you that the truth table is only the key. In problems, the truth table is only that is going to help you to solve the complicated problems in a simple way. The structures will be in the half page long, but the solution will be in just one sentence if you learn how to use the truth table. I will tell you how to write the truth table also. That is not an issue here. Next types of logic gates, sorry, functioning of logic gates, my mistake. First one, NOT gate. Here is the important one. Listen it carefully, listen this carefully and understand what I am saying. This is where we should concentrate more. If you got this, then entire logic gates will be in your hands and nothing goes out from your hands. Each problem you can do in less than 1 minute. I say less than 30 seconds. Okay, nothing is going to be wrong and nothing is going to be more complicated. Everything is easy from here if you focus. Okay, just listen. First of all, NOT gate. What is a NOT gate? If you see one thing, see here. Could you see a circuit here? We are having the resistance, we are having the resistor, we are having the switch, and we are having the battery to complete that whole circuit. Yes, the circuit is not completed yet because the switch is open. Now, do you know that in our homes, in our house, we will have a electrical appliance, whatever it might be. It's a AC, it's a TV, it's a free refrigerator, whatever it might be. If the voltage is high, if voltage is high, then the circuit will break and it will prevent the short circuit and the device will be fine, which means the voltage is low here. The resistor is getting the enough voltage that it can sustain. If okay, I will tell you that if a battery is producing a high voltage here, if a battery is producing a high voltage, then it will break the switch. The switch will be opened and in the side of the resistor the voltage will be less. Means it will prevent the resistor to burn out. Do you got it? What I am saying is, if the voltage is high, we will treat it as 1 because the voltage is high. We will treat it as 1. Why only 1? I will tell you later. Okay, and voltage is low, let's treat it as 0. Why it is 0? I will tell you, wait. If the voltage is low, if the voltage is very low produced by the battery, then the switch will close. Then the switch will close and allow the current to pass through the resistor more. Even though the current is passing like this, but somewhere the switch will open and reduce that voltage. Do you got me? If the voltage is very low, this switch will close and let this resistor getting more voltage that it can perform better, and let us treat it as 1 and this as 0. Why this 0 and 1? I will tell you. Same like this only, the NOT gate. If you give the instruction 0 to pass through it, let us imagine that you are giving a signal to the NOT gate that please pass my 0 signal to the another person. But what will this NOT gate will do? No, it will change the signal and transform it into the 1 and send it to the another person. That is the nature of the NOT gate. Okay, next, what if we keep 1? What if we keep 1? Then NOT gate, you once you imagine what it will do. Yes, definitely it will change it into 0. Means if once we give the signal to pass through it, the NOT gate will transform or reverse that signal and send it to the another person. That what's the NOT gate do if we send a signal through it. Then what we can write for the truth table, sir? What is the truth table of this NOT gate? Nothing. If we imagine this as input and this as output, nothing. If you give 0, it will come out 1. If we give 1, then it will come out as 0. This is only the truth table of the NOT gate. Then what is the Boolean's equation of the NOT gate, sir? If y is equal to a truth, this is not bar. In the logic gates we will pronounce it as truth. What? Truth. If y is equal to a truth, then y equal to not a. Means if you are giving input as a, it will change something, whatever it might be, b, c, d, e, f, g, h, whatever it might be. It will change the signal and it will let through pass and go to the next person. But a is not possible again in the NOT gate. You remember that. I am going to conclude this again. If any signal is passed through the NOT gate, the NOT gate will reverse that signal and give it to another person or another circuit which is attached to it. Okay, the NOT gate business, the NOT gate job is to turn the signal reverse and let it pass through it. That's it, nothing more. Coming to this AND gate, this is very important and very easy structure to understand. Let us now imagine a new structure, that is a new circuit that is involving two switches connected in series, one battery and one bulb. Forgot about that resistor and some those all, and imagine this as a bulb now. Okay, if a battery is sending the power, if this switch is open, these two switches are open, we will divide this into 4 cases, and each case I will discuss what this bulb will do according to the battery, and we will give 1 0 1 0 1 0 0 1 0 1. Remember, these 1 zeros only the thing we are going to deal with the whole logic gates. If you want to learn logic gates, we are going to deal with only 0 and 1, which are also known as binary system. The signals will be transferred in the only the specific way that we will accept, the machine will accept in 0 1 0 1 0 0. This is only the language of the machine that it can understand, machine or that circuit. Okay, the logic gates definition, leave about definition. The logic gates circuits are in that way that they can only understand the language of binary system. What is binary system? The sequence of numbers which are in the 0 1 1 0 0 0. These are the binary systems. Okay, now let us try to understand. Imagine a battery here. Here is a battery, and a switch is open, and another switch is also open. What do you think? This bulb gets glowed? This bulb glows? No, definitely not. If the two switches are open, then I will mark it as 0. This is also the 0. The bulb has glown? No. Again, I will mark it as 0. Okay. In next case, I am going to close this circuit. I am going to close this switch. I have closed this switch, and let us imagine this switch has been closed now. The current is in before, the current can travel up to here only. But when this switch is closed, the current can travel up to here. Yes. Okay. I will mark it as 1 because this switch has been closed. Now this is open. I am keeping another switch open. I am leaving the switch just like that, nothing doing, and I will mark it as 0. If this switch is closed and this is open, the bulb glows? No, definitely not. The circuit is not completed, and here again I should mark 0 because the bulb has not yet glown. Okay. Again I am opening this switch. In the third case, we are talking about third case. I have opened this switch again, and I am marking it as 0. And again I am closing this switch. I have closed this switch, and I am marking it as 1. Will the bulb will glow here in this third case? Definitely not. The current will stuck here. Do you got it? In the fourth case, I am going to close this entire circuit, and I am giving each switch as 1 and 1. In this case, what do you think? The bulb glows? Yes, definitely. The bulb will glow here. I'm marking it as 1. Okay. This is how the AND gate works. This is how the AND gate will work. Actual process of working of AND gate is this. This is how the AND gate will work. Now what is the truth table, sir? Nothing. This is the truth table we are going to try to write. We are going to try this truth table only. Now how to write? Let us imagine first case. In the first case, we have given two inputs. Let us imagine this is the input to the bulb, and the glowing or shutting switch offing of the bulb is the output. Do you got me? If the switches are the inputs of the bulb, then the output will be the glowing or switch offing of the bulb is the output, nothing else. If let come back to the first case. In the first case, the both switches are open, so here 0, here 0, and the bulb glowed? No, definitely not. Then it is 0. Next, in the second case, we have taken the first switch as closed, so it is 1. Next switch as open, it has 0, and bulb glows here? No, definitely not. So it is 0. This is the output, these two are the inputs. Do you got me? This is output and these two are inputs. In the third case, we have taken that the first switch is closed, that is 0, and the next switch is opened. Sorry, the first switch is opened and next second switch is closed. Then it is then bulb has been glown? No, definitely not. So it is 0, nothing more. In the fourth case, we have closed two switches as 1 and 1. Then the bulb glown? Yes, definitely. Then it is 1. This is the truth table of AND gate. This is only the truth table. Okay, then what about Boolean's equation? Nothing. Y is equal to A into B, where y is equal to A and B. Just remember this, nothing more, just remember. Okay, are you sure, are you confirmed that you have understood about the AND gate? And OR gate is more easy, we will get all positive signs here. The OR gate allows in the three cases OR gate will allow the signals here, and in only one case it will avoid passing the signal. Okay, that is very easy. Here see, this is the OR gate, and the circuit of the OR gate is this. In the AND gate, the two switches are in the series, and in the OR gate the two switches are in parallel. Okay, in the OR gate the two switches are in parallel connection, and there is a battery and there is a bulb. Okay, if the battery sends the power, if the first switch is open, I am going to mark it as 0, and next switch is also open, I am marking it as 0. If these two switches are open, then this bulb glows? No, definitely not. I am writing here directly. Okay, you can understand it easily. 0 0, the bulb is not glowing, it is 0. Okay, next, if I close one switch, and when I see this bulb, the current has a path to flow through the battery and bulb. See, the current has the path to flow through the bulb and battery. The circuit is completed. If I keep 1 input and 0 input, and I am seeing that bulb is glowing, yes, so I am getting the positive output as 1, nothing more. If I open this switch again, I have opened this switch again and I have closed this. Now what I should write? 0 1. What are you seeing now? The bulb is glowing? Yes, definitely the bulb is glowing. See, the bulb is getting the path, the power is getting the path to complete the circuit. Yes or no? Yes. So 0 and 1 will result in the 1 output. If I closed these two switches, will the current will flow through the circuit? Yes, definitely. And 1 will result in the output of 1. This is the truth table of OR gate, nothing more. We are already almost finished. Okay, next, what is the Boolean's equation? Y is equal to A plus B, where y is equal to A and B. We are getting almost positive signs. Just remember this Boolean's equation, it will help you. Okay, next, coming to this NAND gate and NOR gate. This is very easy, trust me, these are very easy. We need not to do more hard work in this. Okay, next, let us do this. Here in NAND gate, you are seeing this not here. So how to write this truth table? Do you remember the AND gate's truth table? Here 0 0 1 0 0 1 1 1 are the inputs which we gave to the AND gate. And what are the outputs that we have got? Here 0 0 0 and 1. But no, here it is reverse, because it is having a NOT gate attached to this. What will NOT gate will do? What the NOT gate is trying to do? If the 0 0 is 0, if the 1 0 is 0, if the 0 1 is 0, if 1 1 is 1, these are the common outputs that we are thinking that we will get, but not here. We are having a NOT gate attached. It will always reverse the output results. If 0 0 is there, then output will be 1 because there is a NOT gate here. Okay, don't forget that. If 1 0 is 0, then the result will be 1. If 0 1 will be 0, then result will be 1. If 1 1 is 1, then result will be 0. This is the truth table. Forgot about this and remember this. Okay, these are the results that we are going to get if it is an AND gate, but no, it is not an AND gate. It is the NAND gate. It is NAND gate. That's why we are getting reverse of AND gate. If NAND gate is there, just you remember the truth table of AND gate and reverse the all outputs, you will get NAND gate. What is the Boolean's equation? Y is equal to A truth of A into B, where negotiation of A and B. Y is equal to negotiation of A and B. No, if it is A and B, except A and B, next something else will be the result in that case. Do you got me? If A and B are the inputs and something should be come as output, and the something is not the output we are thinking. Do you got me? If A and B are the outputs, the output is not the A and B, something else will be the result, because there is a NOT gate here. I think I have confused you. What I am saying is, if A and B are the outputs, not inputs, outputs of the NAND gate, the A and B are not going to be the outputs, something else will be the output. That is what the Boolean's equation is telling here. Okay, now coming to this OR gate, NOR gate. Okay, what is about OR gate? First we will write OR gate. 0 0, and here 1 0, 0 1, and 1 1. What we are going to get if we think for the OR gate? It will be obviously 0, it will be 1, it will be 1, it will be 1. But here we have a small twist. We are having NOT gate here, so all the output signals will be transformed. Here we will get 1 0 0 and 0, nothing else. This is the truth table what we are tending. Okay, what is the Boolean's equation? Y is equal to truth of A plus B, where Y is equal to negotiation of A or B. I think you have got understood. If you comment me that you want a problem solving video on this specific logic gates video, then I will definitely make that. If you comment me in the comment box, then we will try to make that logic gates video problem solvings also. Okay, please like, share and subscribe. Thank you for watching. Please subscribe.